Now, after understanding what DMA is, let's try to see where DMA can be kept. Obvious, these things have evolved over the time. This is the first basic version where DMA was kept on the same bus where IO, memory and processor was kept. Only difference it would make is when DMA access is going around, that access would go only between DMA and IO. When require, that time DMA would interrupt processor and inform about certain events. Remaining time, the bus would be used by IO. Now this created a major drawback that if a DMA access goes through the same bus, processor and other devices would have to wait for the memory access. And result, they shifted to the second technique, which is integrated DMA IO. For this, those devices which would require DMA access would have their own DMA controller chips or their own implementation of DMA, due to which this IO would be directly handled by the DMA which they have. Now this could be understood by different set of controllers, for optical, for magnetic, for flash drive, for floppy drive. Each one would have their own implementation of a DMA, giving an advantage that the communication would happen locally. For instance, if this two IO wants to communicate with each other, they will locally communicate through the DMA. The processor is offloaded with the load and can handle its own communication without coming into picture. But what if the device, let's say device number 1 wants to communicate with IO device number 2. Under this scenario, again the option would remain is still communicating through the bus, and the same communication would interfere between the processor and the memory communication. They created another solution for this thing, which is called separate IO bus system. Now what they have done, if you carefully see the diagram and compare it with the other diagrams which we had, in this the bus which we are having was a single bus in both the cases. But now one major change in the design happened was they created two buses. One which was a system bus, which was used by the processor, DMA and other components other than IO in the system for their own communication, and a separately created IO bus which was precisely used by IO. As you can see, the DMA is connected with this bus, so DMA would take entire control in its hand whenever IO is to perform. Now suppose processor wants certain data through IO, that would again go through the DMA access. That means consider IOX is to be read by the processor, so processor would issue a request to DMA that it wants to read from so and so IO. DMA would go read the data or accept the data from IOX, transfer back to DMA. DMA, if needed, would transfer data to the memory, and from the memory it would be taken to the processor. Currently in today's computer we are still using this system. In fact, now along with system and IO bus, we do have separate buses. If we have heard AGP, accelerated graphics port, graphics port, it basically connects CPU and the secondary processor, which is a graphics processor, to each other using a specialized port, creating a system which can have a high data transfer rate and a very high graphical content. So as we talk about the entire video, we understood the evolution. We started knowing and understanding how DMA would look and operate. We provided with the initial solution of DMA using the same bus, then devices using a separate DMA, going to the final solution which today is still implemented and used, is creating two different buses. A system bus for the system operating and the IO bus for IO properties. So guys, that's it. Thanks for watching this video.